Okay, number 8 is, well, it's exponential. The base is 3. That's mean, okay, this exponential is growth exponential. No, however, we have a minus in the front, and the minus in the front indicate us que es reflection. Pero reflection with respect the x-axis. Therefore, the exponential is down. Therefore, in my opinion, this is the option B. It's correct? Do you recognize? Well, to make sure everything understand very well, I double checking using decimals, no? Look, let me show you. Why try? Okay, there you go. Look, question A is y equal, do you see decimals?
Yes.
You see, look, to do the graph of the any exponential, we need only 3 points. The point, in this case, 0, -1. There's -1, no +1, because it's negative, no? Here in the front. The base is 3, +3. The base never is negative. This negative sign is extra -1 that we have, no? And this creates reflection. The traditional exponential that you know, so the base is greater than 1, is exponential growth. However, this is decay. Decay, no, it's decreasing. Yeah, it's decay. Yeah, it's down. It's decreasing because it's reflection. And the classical point would be 0, -1, 1, -3, and -1, -1/3. So everything in the y value is negative. -1, -3, -1/3. And the point in the x is the classical 0, 1, and -1. 0 is the universal point. 1 is the base, que es 3, pero -3. And -1 is the reciprocal of the base, que es 1/3. But of course, -1/3 because we have -1 in the front. So basically, you plot 3 points. You need to know important detail. Any exponential graph has the horizontal asymptote at y equals 0 in that case, no, because we have no vertical shift. Now that's it, and you double checking in decimal if you want. No? And remember, in the test, you send me the picture in decimals, as always you are doing in the other test. Any question? Super clear?
Yes.
I know very well. Let's move on again to the whiteboard. Okay, number 9 is similar. It's another exponential equation graph, no? But in this case, different because the base is 1/2. When the base is less than 1, it's exponential decay. Okay, and also, well, the famous horizontal asymptote is not in 0. No, because we have 1 -3 can indicate us okay, this is the vertical shift 3 units down, no? It's 3 units down. Therefore, let me try to understand this. The answer is in another page. 3 units down, but it's exponential. I suppose case, yeah, for sure I say. It's A for different reason. Reason number 1, the horizontal is a -3, no? And domain, you know, is classical. Domain is all real number always in the exponential function. And the range is from -3, not including -3 of course, because this is asymptotically. Our curve approaches but never touch. From -3 to infinity positive because it go up. Well, go up in the y value, no. However, it's obvious that function is decreasing. And determine the point is a little bit more complicated, but we can do that. Actually, in decimal, I did that. Do you want to see decimal or not? No. Do you understand very well that the option A is the correct option?
Can you show it in decimals?
Okay, why not? Why not? Okay, do you see? Okay, that was the question 8. Now question 9. Question 9 is something like that. Okay. The point is a little bit weird because actually we a horizontal shift. So now this change the number, right? But you are in 0. I have the point here, because you know it's a fraction, weird fraction. I evaluate the point. We have the famous 3 point. And also I have the y-intercept and the x-intercept. It's super easy because suppose you want to find the y-intercept, you evaluate 0, x equals 0. And you know, x-intercept is a little bit more complicated. You put equal to 0 and solve for this exponential equation. Apply logarithm maybe, right? But the most important is the base is 1/2. It's exponential decay, is going down. And the asymptote is located at y equal -3. No? More clear?
Yes.
Okay, super. Let's move on again to the whiteboard. Okay, next question is easy. It's just a conversion from exponential to logarithmic or logarithmic to exponential, you know? Okay, for example, in number 10, do you see whiteboard, right? It's giving this statement, que es logaritmo base 3 of 243 equal b, no? And how you change to exponential? Well, it's obvious that the base is 3. The exponent is b, and the result is 243. Que corresponde with the option A. Correct? Everyone follow me?
Yes.
Yes.
The question 11 and the rest 12, 13, and so on is completely, well, it's the same. And you have the logarithm statement and you convert it to exponential. Entonces es easy, you copy the base is 3. The exponent always is the answer for the logarithm is equal 1/243. Okay? Is conversion logarithm statement to exponential. You need to be strong in that part, guys. Okay? So far, it's okay? Any question? What part is confused? What part you don't understand very well? Clear? Answer me.
It's clear.
Okay, good. Let's move to the page number 7. Page number 7. Is that one, I suppose, no? Yeah. Okay, again, it's the same thing. Is we have the logarithmic statement and you change to exponential. Okay, number 12 say logarithm base 4 of, look, logarithm base 4 of 1/64. This is the number inside the argument is equal to -3, no? And when you change to exponential, the base is 4, the exponent is -3, and the result is 1/64. Is the option B. And number 13, this was 12, and number 13 is logarithm base 49 of 7 is equal to 1/2. When you change to the exponential, the base is 49, the exponent is 1/2, and the result is 7. Okay? And remember, raised to the fraction exponent is equivalent to, say, square root 49, and this is super good. It's very, very understandable. Clear?
Yes.
Clear.
Now is 1415 is Bauer. 1415 is Bauer. Is given the exponential statement, and you need to switch into logarithmic. Okay, do it. Mm-hmm. 14 is a to the third power, no? A third, yeah. Is equal to b. How are you switching to logarithmic? To log. Well, you write the word log, and you put a small number here that corresponds with the base, que is a. You put something inside the argument, and the result of the logarithm always is exponent, 3. And this is b. Okay, logarithm of base a of b equal 3. Boom, option B. And 15 is similar. Is 4 to the -3 equal 1/64. When you switch into logarithm, it's a log g. The base is 4 of the one number, and the result always give me the exponent, que es -3. Okay, let me see. D. Good. Easy. Easy. Okay, let's compute it now. Let's compute it now. 16. So far, no problem, guys. Okay. I suppose que my plan is today I cannot finish the review. So we continue Tuesday. And Tuesday I will send the test number 3, no? Que will be due Thursday of the next week, next Thursday. Entonces I change, don't worry, I change the due date in Alex for that day. Okay? The most important is now that you understand very well everything. Okay, let's move in 16. 16 is simplify. Simplify? No, it's compute. Logarithm base 9 of the 1/81 is equal to something I have no idea. So you switch into exponential. The base is 9. The exponent is the thing I try to find. And the result is 81. 1/81. I know that 81 is 9 squared. And reciprocal es negative exponent. Es obvio que x is equal to -2. There you go. That answer. Clear? Another possibility.
Yes.
Another possibility. Suppose I never understand this. Okay, no problem. You apply chain of base formula and you using standard logarithm, and you compare logarithm of 1 over 81 divided by logarithm of 9. Okay, you put in the calculator and you get this answer. I promise. Do you want to show you in the calculator, in the online calculator, or no? Or you try to do by yourself? I need to understand what way you prefer. Remember, we have by hand using in the definition and intuition of the conversion, no? Logarithmic statement to exponential, manipulate the basis in order to express it using common base. It's one possibility. Not always it's possible to apply that, but frequently. And another possibility is you change the base. In our example, the base is 9. 9 is non-standard base. You switching to a standard base, maybe natural or common, and put in a calculator, no? What way you prefer? What way you prefer? A calculator or by hand?
By hand and then checking on the calculator.
Good. I'm checking with the calculator. Do you want I show you how? Or you are doing by yourself right now in your own calculator? Let me know. Do you want I open the online calculator? Online calculator is a little bit weird. But
Maybe more difficult problems.
Maybe more difficult problem. This is too easy, right? I understand. She say maybe in the more complicated problem, this is too easy. Okay. Okay. So let's move into the what page? What is the next page? 8. Everyone follow me, no? Okay.
Yeah.
Excellent. Okay, with that. There you go. That page. Well, that page is a logarithmic graphic. Logarithmic graphic, remember, normally any logarithmic graphic passing through the famous point 1,0. And we have two kinds. The logarithm when the base is greater than 1 is like that. It's when the base is greater than 1. And another logarithm when the base is less than 1. Case like that. Base, in between 0 and 1. Because never the base is negative. And in both scenarios, we have the vertical asymptote here. Okay, entonces the base is 8. It's obvious que my graph look like similar to the red one, no? Makes sense, right? Well, automatically I discard this possibility and this possibility. So maybe this or maybe that. Okay. I know the logarithm of base 8 of A is 1, no? Let me make it zoom. Oh, yes, absolutely good. Look, A is 1. This is the answer. And you don't see, of course, clear. The vertical asymptote is no explicit show you, but you know, remember our test is no multiple choice. Now, see, I say one question, do the graph. You are doing the graph. Of course, you are doing this one, no? And don't forget, include the vertical asymptote in this case at x equals 0. Do you want to see decimals for this problem? Yes or no?
Yeah.
You want to see? Yeah. Okay. No problem. Guys, we have time to do perfectly everything. Decimals. Switching to decimals. Okay. Do you see decimals? Okay. We are talking about 17. 17 is, you know, logarithm base a of x. And the point que I select was the famous 1,0. Let me make it zoom. A, 1, and 1 over a, negative 1. And don't forget the important vertical asymptote at x equals 0. Super nice. Exponential no, logarithmic graphic. Okay? Any question? No problema. Okay. Move on to whiteboard. Okay, now we have some exponential equations and logarithmic equations. Okay. Number 18. Say 2 to the 3y, I suppose it's 3, no? Yeah, equals 64. Okay, this is the classical exponential equation that we can solve, manipulate both sides and express it in the common base, because I know the 64 is 2 to the 6th power, no? So 2 times 2 times 2 times 2, or whatever, you know, 64. I remember gets 8 times a. Actually, a is 2, 2, 2, 2, 2, 2. Actually, 1, 2, 3, 4, 5, 6, 2 to the 6th power. Now, in this moment, I know if you have two exponential and the base is the same, it's because the exponent is the same. So 3y equals 6 divided by 3 both sides, y2. Boom. And the answer is 2, is the option A. Clear? Some students say, well, professor, I can apply logarithm both sides. You can, always. This is universal. You apply. And finally, you ending. Well, no. Yeah, well, let me see. Suppose that students, I never understand this. You apply logarithm, okay? Logarithm of what? 2, 3y is equal logarithm of 64. Suppose I apply natural. I don't know why. You apply the property number 7, the exponent go to the front, 3y, natural logarithm of 2, and natural logarithm of 64, no? Now, y alone is natural logarithm of 64 divided by 3 times natural logarithm of 2. And you put in a calculator, and that's it. Oh, no, in this case, no. No. Why not? Because I know that 64 is 2 to the 6th power. And these 6 go to the front, apply the property number 7. And you can see clear the logarithm to cancel out, and 6 divided by 3 is 2 again. What way you prefer? The first one or the second?
The first way.
Yeah, me too. Me too. Okay, let's go to 19. 19 is a logarithmic equation. Okay, let me copy. Is 19 ln of x plus ln x minus 7 equal ln of 4x minus 18. Okay. There are many ways to solve that. However, in my opinion, the easy and more sure way is you not necessarily bring any logarithm to the one side. No. You condensing this and this together. So it's a logarithm of x times x minus 7. You multiply this expression, and this is inside the argument. Okay. And that moment, if you have two logarithms and the base is the same because it's the same kind of logarithm, it's obvious that the argument is the same. And you definitely ending the problem in one equation. Okay, by the way, this is quadratic equation. No? Apply distributive property, x squared minus 7x minus 4x plus 18 equal to 0. I realize that when you multiply here, you get x squared. It's a quadratic equation. No? Now you solve for no combined like term, x squared minus 11 x plus 18 equal to 0. You ending in quadratic equation. This quadratic equation is easy because by factorization is possible, no? You can apply if you want quadratic formula, no? But in this case, my recommendation is when you see the combination, the combination obviously is 9 and 2, no? 9 times 2 is 18, and 9 plus 2 is 11, no? And this sign is negative both. So we have two solutions. The solution is x equal 9 and x equal 2. This is the potential solution. And mandatory, you need to verify this solution into the original equation to verify that both are good or one is good, another not good. And the checking is important part. If you forgot, you have no full credit in this question. Suppose checking for 9. Okay, natural logarithm of 9 plus natural logarithm of 9 minus 7 should be equal, claim that natural logarithm of 4 times 9 minus 18. Okay, natural logarithm of 9 stayed the same. Plus natural logarithm of 2, no? Because 9 minus 7 is 2, should be equal natural logarithm of this is 36 minus 18 is 18. Wow, fantastic! Because when you condense in these two logarithms only one, you multiply, apply the property number 5. Entonces, logarithm of 18 is equal logarithm of 18. True statement. That means that the solution is super good. Let's move on to the checking for 2. Logarithm of 2, I plug it in the original equation, plus logarithm of 2 minus 7 should be equal, clean again, logarithm of 4 times 2 minus 18. It's obvious it doesn't work because automatically you see inside the argument negative number, in this case logarithm of negative 5, and here we have another, no, -10, negative 10, I could suppose, no, logarithm of, this is a, this is negative 10. Immediately you see this is completely out of the domain. This is error, mistake, undefined. Therefore, the solution 2 is wrong. And the only solution can have this equation is 9. Let me check it in the choice that we have. We have 2 and 9, 9 alone, 2 alone, or empty. No, it's 9. It's 9. Any question, guys? Any question? Go ahead.
So even if both sides are still the same, it's like even if they're negative, it's not true.
Exactly. Suppose that you want to continue. You say because you condensing this. No. This is not true. This is undefined. This is, you say, we are working in the real numbers. In the real number, logarithm of -5 is undefined. Undefined. This is undefined. This is, yes, it's okay, but this is not okay. Right. Good question, miss. Independent of the you, so far you see a true statement, but logarithms do not accept negative number. No, it's illegal. Okay, any other question? Let's move on to the word problem. We have a lot of word problems. That means that the word problem is important in this test. It's application, no? The first one is easy. It's a typical problem of the compound interest, in which you have in the 20, you have the present value is $1,000, and the interest rate is 6%, is in decimal 0.06, and compounded annually. Annually means que n is 1, and t is 6 years. You need to find future value. Yeah, future value. Future value is equal present value 1 plus r divided by n multiplication nt. In our specific example, this is 1,000. 1 plus 0.06 divided by 1, and the exponent is the multiplication nt, pero n is 1 is 6. So actually is 1,000 1.06 raised to the 6th power, because 0.06 divided by 1 is 0.06, and 0.06 plus 1 is 1.06. So say I put in my calculator is 1,000. Come on, help me. 1,000 multiplication parenthesis 1.06 close the parenthesis power 6. Boom, I get the answer. Remember, you round to the nearest cent, que is like a thousandth. Come on, help me. Everyone working with the calculator, guys. This is important. Without calculator, you don't pass this test. Go ahead. What answer you get?
1,418.
1,418, and how many cents?
52.
Absolutely perfect. Everyone get that?
Yes.
It's easy or no? Okay. Let's move on to the next one. Number 21. In number 21, the present value is the same. The interest rate is 10%. The R is 0.1. Compounded semi-annually is n equal to 2 times in 1 year, and t is 8 years. And the formula is future value is equal present value 1 plus r over m raised to the n. It's 1000 1 plus 0.1 divided by 2 raised to the 16 as exponent, as a multiplication 8 times 2. No? Actually, well, you divide first. You put in a calculator like that if you want, no? But no, I like to manipulate a little bit by hand. This is 1 plus 0.05. And together is 1.05 raised to the 16 power. Okay, calculator now. 1000 multiplication, parenthesis, 1.05, close the parenthesis, power 16. I got it. I waiting for you.
1.8. I got 182 with 87 cents.
Yes, you're right. Guys, some students have problem to put in the calculator this, because I can do that in the calculator online, no? You see a little bit. No, it's similar to your own calculator, no? But this, some students have problem with the calculator. No?
No.
Okay, super. Okay, next page is the page number 9. Erase everything, right? Okay. Page number 9. Okay. Well, let me see which one. This one. Okay. Okay, now it's important that you will be able to identify what kind of problem we have. Remember, we studied, let me refresh your memory, exponential growth, exponential decay, Newton cooling process, and we have another kind of problem, but it's not extremely important, but one I want to cover in the review, the logistic model. Okay, so now your identification. 22 is a problem talking about population. Population of what? Of the black nose rabbit. And say in 1990, we have 120, no? It's initial. Remember the formula. What is the formula for the growth population? Population 20 times es equal to null, que representa initial, exponential, KT. And K working somehow like a R in money, no? It's the rate of change of the exponential. So K give me the information how fast increasing the population, no? See, K is bigger, it's increasing faster. But P null is obvious que es 120. So my specific formula is 120 rabbit at the beginning at t equals 0 exponential KT. But as always happen in that problem, we don't know K, we don't know T. Therefore, I need extra information. Okay, the problem say, let me try to make a sketch to understand this. This is the line of time. And this is the line of rabbit, no? Population. At the beginning, we have 120. And this situation happened in 1990. Que I consider que this is t equals 0. Now population growth like that, boom. In 1993, que es 3 years, is t equal 3. T is measured in years, no problem. We have 240. Whoa, it was increasing too fast. No, like that. I predict. $240 is double. 240. Pero it's not linear, it's exponential. See, in the first 3 years increases double. Entonces now it's increasing more. Entonces now I need to find the right population follow the exponential law. Okay. Exponential law is this equation. Exponential law. How many rabbits in a year? Okay. Just t equal 8. I need to investigate. Boom. This is 4. A is, I don't know. How many rabbits we have here? This is my goal. How many rabbits? Okay, entonces I have, as always, condition 0, que es the initial. Condition 1, in which we have whole information, time, and rabbit amount. And this allows me to find the k. And k give me information how fast increasing the exponential. And finally, condition 2, in which you have incompleted. We have the time, but we have no rabbit. Okay? But remember, our problem contains two parts. And the first part, you apply the condition 1. The condition 1, the population is 240. So 240 is this, 240. Because actually, this is equivalent to say population at 3, no? 120 exponential k, que I have an idea, times 3. In this moment, this is condition 1 we apply. Okay, so we have in that moment exponential equation, and the only unknown, okay, we have a k. So you divide it by 120 both sides. It's obvious 2, no? Because 240 divided by 122 e to the 3k. Super. In that moment, I apply logarithm of both sides. What kind? I prefer is natural because the base is e. So logarithm of 2 is equal logarithm of e to the 3k. Okay, you know very well, okay, when they are coincidence in the base of the logarithm on the base of the exponential on those each other, and the answer is 3k. Therefore, k is equal divided by 3. Es logaritmo 2 over 3. This is k. You leave it like that if you want, or you put in the calculator. Remember, you put in the calculator, you store this number in the memory of the calculator, because this is not the final answer, it's the partial answer, no? So to don't lose accuracy in the answer, no copy in the piece of paper, because when you copy in the piece of paper, you trunk a digit, no? And you store in memory. One possibility is leave like that, like exact answer. In the last moment, let me see what is the most convenient way. Okay, I don't remember very well. Condition 2 now, here's the final part. In condition 2, I need to find the population at 8. Okay, I have no idea. And this is 120 e to the k times 8. Entonces 120 e, pero k es natural logarithm of 2 divided by 3 times 8. And this is, be careful. Let me erase this. Not clear. 120 e, and the exponent part of e, I copy ln of 2 divided by 3 times 8, right? And you can put it like that in the calculator. Or either way, the way you prefer. Put in the calculator first this. Calculator now here. Store in the memory. And using this memory to plug it in here, decay. Okay, let me try my best. Okay, I put in a calculator natural logarithm of 2. Natural logarithm of 2. Sure. Natural logarithm of 2. Okay. Divided by 3. And yeah, I store a memory. STO. Normally the calculator have a key is STO. STO is a memory. You select the memory. In this case, I have different possibilities to assign. I assign K value. K. Who is K? There you go. I found. Now in my calculator, K is no K. It's a number. Finally, I put 120. 120 multiplication, exponential with the base key, of course. I put in the arguments K times A or AK, whatever. A times K. A times K. Let me see. K here over there. Okay, I press equal sign. I get the answer. Wow, amazing. Okay, let me know what answer you get. I want to compare my answer I have in this moment by hand, in my hand, with the calculator, with the option to offer the problems. This is important moment, guys. So you don't understand very well this, you are in big trouble. I can clarify everything. Nobody get answer?
I got 0.23, but I don't think that's right.
What do you say? Again, repeat again. What is the answer?
0.23, but I think
No. I have no sense. The population of the rabbit started in 120 rabbit, and its population growth, of course, bigger than 120. No, it's 500, 600, something, no?
761.
Excellent. She said 761 point what? 0.95, no? 0.95, by a lot of digits. I don't care. But you know that the rabbit is a whole number, right? No decimal rabbit. So say the answer is 762. Some student wants, can I try to do in your online calculator or no? Yes or no?
Yes.
Okay, let's do it. Well, let me try. Desmos calculator. This calculator is a little bit weird, you know. That's okay. Okay. Open browser. Okay. Control B. This is Desmos Scientific. Okay, there you go. Beautiful. I want to share the calculator. Wait, here, over there. There you go. Do you see? Oh no.
Yes.
Do you see? Do you see now or no?
Yes.
Let me try to put together calculator and whiteboard. You see, in that moment, you see, it's important to me. You see only the calculator, no? And your screen of the computer, you see calculator only, no? Yes or no?
Yes.
Because in my screen, no. In my screen, I put together the whiteboard and the, but I need to know. Okay, so basically is 120 multiplication, entonces in the function I try to find exponential. Oh, there you go. I saw exponential here, exponential. Entonces in the exponent I put logarithm of 2 multiplication. No. Multiplication, the exponent. We continue in the exponent. Multiplication by 8 over 3, no? 8 and divided by 3, no? It's the same, right? Divided by 3. Boom, I got it. It's 761.95. Of course, you round off to the near whole number because it's a rabbit. That's a 762. Clear?
Yes.
Clear? Excellent. Any other question? Okay. Okay, let's move on to the question 23. Is again similar, no? Population of the particular country was, okay, the formula for the growth population is population to any time is initial e to the k. And normally,
Yes.
sorry. I forgot. You see now?
Yes.
You see now? Yeah. Thank you. Entonces, remember, 3 conditions, 0, 1, 2. Condition 0 is the initial, and the initial was 1985. Okay, it was 29 million. Okay, no, not necessarily too many 0. You consider que es 29. I know default que es million. Okay, I use in condition 0 at t equals 0. Okay, at t equals 0, and our problem is 1985. 19, 9, no 8. 85. However, in 1990, que es t equal 5 years, no? After that, the population is 40. Wow, increasing too fast. This is condition 1. Condition 1. Entonces, this condition 1, in which you have whole information, 5 years, 40 million, because population at 5 years after the 1985, que es 1990, is 40 million. Okay, allow me find the k value. Divided by 29. 40 divided by 29 is equal e to the 5k. Now you apply logarithm, natural of course, by the same reason. And when you apply logarithm here, you know que logarithm and exponential on each other and the answer 5k. Therefore, my famous k is natural logarithm of 40 over 29 divided by 5 is k. Okay? And you leave it like that, or you put in a calculator, compute the decimal approximation, store in memory, and we're waiting for the condition 2. Condition 2, let me see, what's the condition 2? The exponential growth function is equal to 29. Thank you for giving me this information. Describe the population for the country T years after the 1985, using the fact that 5 years, using the fact that at 5 years after the population increases 11 million, pero es 40 o... 11. Okay, 11 after. Okay, 11. I understand now. Okay. So they want to know the condition 2 is when the t is equal to 11. Bueno, plug it in. That's it. Plug it in where? Here. Population 11 year after the 1985 is equal to 29. Multiplication, exponential, and the exponent we have k. K is natural logarithm of 40 over 29 divided by 5 and multiplication by 11, no? A multiplication by 11 que es t for this condition. And another possibility, you put this in your calculator. I don't know if it's complicated or not. If it's complicated, you put this first ball in the calculator and you store in memory. And you use in the memory in the second piece. It's doing. I want to do in my calculator. Come on, try to follow me. Either way, the way you prefer. Logarithm of 40 divided by 29. And outside the parenthesis divided by 5. I can put that. Okay. PI safe and a memory. Memory K. Okay, now finally 29 multiplication, exponential. And exponent I put K multiplication by 11. Boom. I got it. Wait. No. I interpreted wrong this. No, I did wrong. Hello. Okay, they want to know. I'm crazy. Easy. They want to find the K. Find the K. Only K. K alone. Okay, this is easier. Wow. K alone. K is, I got it. S 0.64. So they want to know, no, completed the problem. No. So that part, no. That part, no. Only that part. I put in the calculator, run, and the answer is 0.064. So the K value, okay, the rate of change of the exponential is 0.64. Okay, good. You get the idea? You put in the calculator? No problem with the calculator? Answer me.
No problem.
Okay. Okay, let's move on to question. Next question. Okay, the question. Is the question 24. This is classical. When you hear half-life, this is the game. So this is exponential, but it's going down. decreasing. Entonces now we have a half-life of silicon. It's a chemical element. Is 7, so half-life is 7. Okay, I don't remember very well half-life, what the hell is that? However, I know, okay, this is about isotope, radioactive isotope. At the beginning, look, we have 10 grams. So at t equals 0, we have available 10 grams of the silicon 32. And this is decreasing, decay. And the formula for the decay is amount of substance to any time is equal to A null, que is the initial, que by the way is 10 in our example, e to the k. What is the reason it's going down? Because when I found, or I tried to find k value, k is negative. And when k is negative, entonces es decay. Actually, the base is not e, is 1 over e, reciprocal. When the negative exponent, reciprocal. So now we have 10 grams. How much will be present in 100, wow, 100 years. Okay, half-life is the time, is 7, 10 years. Wow, a lot of time. It's present half, okay, 5 grams. However, they want to investigate 100. Okay, 100 is smaller, 100 maybe here. 100 years. How many grams? My common sense is the answer in between 5 and 10, no? I don't know. Maybe close to 10. I don't know. I have no idea. I try. So now condition 0. Condition 0 is 10. Okay, entonces, amount of substance to any time is equal to 10 exponential KT. I'm using condition 1. Okay, condition 1 is the condition gets given whole thing. The time is given, the amount of substance is given to find the K value. Okay, super. Now, in that moment, we have 5 grams. 10 grams e to the K. I have no idea who is K, but I have the idea. The time is 7, 10 years. And the time in our problem is measured in years. Okay, ready. Divided by 10 both sides. Oh, easy. 5 divided by 10, 1/2. E to the 17. Okay, apply logarithm both sides. You know, que logarithm and exponential, when they have the same base, undos each other, cancel out mentally in my mind. And the answer is 17K. Okay, now 17K divided by 710, both sides. Logarithm of 1/2 divided by 17, okay. And you see clear now que 10 is negative because logarithm of the number less than 1 is negative. Never the answer. I put in the calculator. I put in the calculator logarithm of ln. You see in that problem always we use ln. So ln is famous in that problem, okay, science problem. Logarithm of 1/2. 1/2. Close the parenthesis divided by 17. Press enter. Wow, you get the weird answer. I don't care this weird answer. I don't copy in the piece of paper because it affects my eyes. However, I store in the memory. Store in the memory K, alpha K. There you go. I have K in my memory. And we use it for the second part. And the second part, in the condition 2, is this condition 2. Okay. I'm using the same formula, no? But amount substance to a specific time que I have no idea is, yeah, I know what it is. It's 100 years. Sorry. Entonces es 100 years. It's the thing I want to find. This is my goal. Amount substance in 100 years is equal 10 exponential k is that number I have in the memory of my calculator, multiplication by 100. Okay, now ready. Put in the calculator this. This is 10 multiplication exponential. Inside the arguments of the exponential, inside the parentheses, I put k, alpha k, multiplication by 100 years. Close the parenthesis and press enter. Oh, I get the answer. You get some answers or no? Guy, this is complicated or easy? Come on, I need to feedback. That part is easy or it's complicated? Hey. A ver, this is easy. Will say easy. Another opinion. Will say it's easy. Good for Will. You get the answer, Will? How many grams? Basically, is the gram of the system in 100 years.
Professor, I don't know because I think I did it wrong.
You did wrong. What? Well, the answer is, okay, I get in my calculator, of course, is 9.9. I predict this, 0.6. Que 907, because the next digit after the 6 is 9. Okay, entonces you truncate around of 0.7. Que es this answer. Do you want guys show you on the calculator again? For you specifically, Miss?
Yes.
Okay, let me try. Let me try. Okay, I want to copy in one piece of paper. Actually, the thing I try to do in my calculator is 10 multiplication exponential in the exponent I put natural logarithm 1/2 divided by 17 and multiplication by 100. That's the thing I try. Let me try to do my best. Okay, where is my calculator online? Here. Okay. Let me share. Do you see my calculator online or not yet? Do you see or no?
Yes.
Okay. I want to clear everything. The thing I tried to put in the calculator is 10 multiplication exponential function. In the exponent, I put every crazy thing. It's natural logarithm of 2. Of 1/2. 1 divided by 2. Okay. Totally outside the parentheses because it's outside the logarithm. U divided by 17 and multiplied by 100. It doesn't matter the order. In this case, I prefer, I don't know why, multiplication by 100. Oh, no, coño. Inside the exponent. A ver, I move. Okay. Time. No. A ver. How do you do that? No inside. Entonces I do outside here. Multiplication by 100. And divided by Yeah, divided by 17. There you go. Is the answer. Okay, this is the correct way to put in this online calculator. And my calculator, no, I did different because my calculator is good. It's better than this. But no, it doesn't matter. In the regular calculator, you are doing this. I recommend, highly recommend, use the memory to store the partial answer. You get Miss? Now?
Yes, thank you.
Excellent. Okay, let's move on to the next problem. Okay. 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 Wow. Wow. Let me see again. Do you see whiteboard or no? I'm not sure you see. You see whiteboard?
Yes,
No?
yes, yes.
Okay, okay, so, super. Okay, 25 is similar. It's the K problem. Because talking about the same half-life. Wow, it's important to say. Plutonium, plutonium, plutonium 234 is 9 hours. Okay, 60 milligram is present now, present value. Present value, no. Amount of substance, okay. Remember the formula is amount of substance to any time is initial A null e to the KT. Entonces, A null es obvio que es 60 milligram. 60 milligram. E KT. Condition 0. Allow me determine A null. How much will be present in 6 days? So now, remember the graph. The graph, at least for me, help me to understand the problem. I don't know if do you lie or you don't lie, no? This is the initial 60 gram at equals 0. And this is the K. And the half indicate half, so 30. 30 happen in this time, que es the half-life, que es 9 hours. Y I want to investigate what happened in 6 days. Entonces now 6 days is 24 hours multiplied by 6, no? Because I want to express everything using the same unit, no? Because half-life is expressed in hour, and my problem in the condition 2 is in day, entonces there are contradiction for the unit, no? I need to express everything using every same unit, or you convert hour to day, or you convert day to hour. I suppose it's better 24 times 6, 144. So basically, the thing I want to investigate hours is what amount of substance we have in 144 hours. Here. This is my goal. So now we have condition 0. We have condition 1. Okay, allow me find the K value, and condition 2 in which you have the time, but we have no the gram or milligram of the substance. I don't know. Do you like the graphic to understand the idea? This is a visual interpretation, no? Do you like or no? Come on, guy, answer me.
Yes, yes.
Pero you need or no? I need.
Yes, it helps.
Yeah. Okay, entonces let's move on to condition 1 to find the K value. The amount of substance in the condition 1 is 30. 30 60 e to the k times 9. So for k, 30 divided by 60 is 1/2 again. And it's happening always is 1/2 because it's the half-life. Now apply logarithm on both sides, logarithm 1/2 divided by 9 is k. I don't want to repeat this. It's clear, right? Now I go to the condition 2. In the condition 2, we apply the same formula, but I want to find what is the amount of substance in 144 hours. Is 60 times E raised to the natural logarithm of 1/2 multiplication or division by 9 and multiplication by 144. This is the thing I try. Come on, guys, do it. Come on. Is well, you can put the first k, natural logarithm of k, natural logarithm of 1/2. 1/2, close the parenthesis, divided by 9. Boom, I got it. Now you store this information in the memory. Good. Now I go to the formula, 60 times exponential k times 144. Close the parenthesis, press enter. It's weird. Let me see. We have let me see the answer. We have a 0.00. Okay, the answer I get in my calculator it was 0. How many 0? 1, 2, 3, 91. Okay, entonces es, I suppose que si you need to round, the only solution that have a little bit sense is the C, because you try to round off to this guy is 9, entonces increase, entonces 0.001, get that one. Confusing? That was the answer of this in my calculator. Yeah, round off to this. Any question, guy? Too much, eh? Okay, I can erase or no? You follow me or no?
Yes.
Okay.
Yes.
Let's do one more. Let's do one more problem. And the rest we continue next week. Okay, 26. 26 is similar, no? It's the decay problem. A fossilized leaf contain 27 of the normal amount carbon-14, the famous carbon-14 that we use in archaeology, the test of carbon-14. So now what's the idea? The idea is decay problem again. Time and amount of substance to any time. Okay, entonces the fossilized leaf contain 27. Well, at the beginning, I suppose que es 100%. So alone, years ago, we have 100%. In this moment, in the present time, we have 27. And I suppose que our goal is investigate what is this time. I suppose. Let me read the problem again. See how old the fossil to the, okay, assume que 5600 years is the half-life. So half-life is 50%. Corresponding with this time que es 5600 years. Clear the idea? Entonces we have condition 0, condition 1, and condition 2. Wow. Condition 2. All we have amount of substance to any time is equal A null e to the k. Esa es fórmula. Using condition 0, I know that A null is 100.
Professor, why is it 50 again?
What? T?
Why is it 50? Why did you put 50?
What do you put? 5600, you say?
No, 50. Just 50.
Ah, good. Because of half-life. See, in Nietzsche we have 100% because this is measured in relative unit, not in gram, milligram, no. 100% is the whole thing. And the half is 50, right?
Yes, thank you.
Good question, good question. So sometimes the problem is given exactly in the absolute unit, gram, milligram, like in the problem 24 and 25, but on the problem 26, no. Everything is expressed in percentage. So the whole thing, because at the beginning, is 100. And the half-life duration is 50. The amount of substance decay, half. Okay. And so using condition 0, A null is 100. E to the k. Condition 0, I use it. And as always happen, condition 1 is used to find k. Okay, in the condition 1, we have 50. That's the amount of substance. 100 e to the k multiplication by 5600 years gets our half-life of this chemical element, que es carbon 14. Okay, divided by 100 both sides. Again, happen in that problem, get 1/2 here always. You see that? E to the something, to the 5600 k. Apply logarithm both sides, ln of 1/2 divided by 5600 is k. Okay, I finished the condition 1 to allow me find k always. I go to condition 2. In condition 2, you know that the relative amount of unit is 27%. In the formula we have 27 is equal 100 exponential k, I have k in my hand, que is that value. One possibility is you compute separately and put in the memory of the calculator, or no, or put together, everything together. It's a little bit more complicated, but it's okay. K time, T, que I have no idea who is T. No, I have no idea. Therefore, I apply this again. We have exponential equation, pero es exponential equation que mandatory. You need to apply logarithm, no? You divide by 100, both sides. You apply logarithm of both sides. You have logarithm of 27 over 100 is equal KT, no? Therefore, T, que is our goal, is divided by K. And K is that value. I just plug it in. So some students say, well, okay, I have no memory. I don't know how to manipulate memory. You put it in the calculator like that. Or, see you it's confusing that part, you put it like that. And multiplication by 5600, no? Because you know this is this guy and reciprocal this multiplication and get the same answer. Let me try. I prefer the way, okay, put in a calculator. I store in the memory partial answer. Natural logarithm of no. Natural logarithm of 1/2 divided by 5600. Okay, I compute that. I store in memory. That's it. Now ready. Actually, it's again logarithm of 27 divided by 100. Close the parenthesis, division k. Division k. Okay, I get the answer. Wow, it's a lot of years. Is at least in my calculator I get 10,500. 500 no. All right, let me see. See, yeah, 578. Decimal, no, 22. It's not important. This is not significant thing. Years. Get the idea. 10,000 something. Let me see. 10,000 before Christ. 10,000. This is the answer. Well, approximately, you know. What is the close answer? Of course, our test is not multiple choice. Therefore, you don't need to select anything. You only copy that. And end the story. Clear or no? Well, I suppose you are so tired. Yeah. I suppose you are so tired. And not necessarily to continue, no? We have another day. So now that you are still working in the homework and the test online will be due next Thursday. Okay, I need to change that. Okay, but I don't do that. However, I want to change. Don't worry. So we have that this weekend you can enjoy peaceful because you have no pressure of anything. One of the homework study, no? But next Tuesday we finish for sure the review, and I will send the test, the written test. I change the due date for the online. Okay, everything is clear? Everything is clear or confusing? Come on, question.
Is the homework also due next week?
Yeah. I change both. I change the homework, I change the test, miss. Yes. Okay, good question. Excellent question. Okay, entonces, have a nice day. I need to prepare another class that I have now. Thank you.
Thanks, sir.
Bye-bye.